Let's start the show. Hello children. My name is Albert Einstein and today I am here to tell you my research on light which I had discovered with a lot of efforts. Light. What is light basically? Bulb, sun, tube light, or magic? Well, the definition of light is that it is an electromagnetic wave having wavelength in between 400 to 700 nanometers, that means invisible region, with a velocity of about 300 million meter per second and exhibits both wave and particle nature. Now coming to the next topic, let us talk about the wave and particle nature of the light. Based on the particle and wave nature of light, many theories were proposed, out of which some of the famous theories are. First theory is by Isaac Newton. Known for his law of universal gravitation, English physicist Sir Isaac Newton realized that light had frequency-like properties when he used a prism to split sunlight into its component colors. Nevertheless, he thought that light was a particle because the periphery of the shadows it created was extremely sharp and clear. The second theory is of Huygens and Grimaldi.
The wave theory, which maintains that light is a wave, was proposed around the same time as Newton's theory. In 1665, Italian physicist Francesco Maria Grimaldi discovered the phenomenon of light diffraction and pointed out that it resembles the behavior of waves. Then, in 1678, Dutch physicist Christian Herns established the wave theory of light and announced the Herns principle. The third theory is proposed by James Clerk Maxwell. James Clerk Maxwell has stated that light is a wave by explaining its electromagnetic nature, that light travels forward by the action of electric and magnetic fields in perpendicular direction.
Well, remember one thing, that whenever a light wave propagates, it will always shows the reflection, refraction, radiation and dispersion in any situation. Now let us talk about the reflection. There are two types of reflections. They are specular reflection, diffuse reflection. In the diagram you can see that how the reflection of light takes place. This type of reflection is called as specular reflection, in which the direction of the reflected ray can be determined by the angle of incident. In the diagram you can see that there is one incident ray and many reflected rays. This type of reflection is called as diffuse reflection. There are two types of mirrors which are used basically in daily life. First one is concave mirror. Another is convex mirror. The following are the cases shown in concave mirror. In case 1, when the object is at infinity, the image formed is point-sized at the focus. In case 2, the object is beyond C, the image formed is between C and F and it is of less size than the object with a nature of real and inverted. In case 3, the object is at C, the image formed will be at same position and of same size with inverted nature. In case 4, when the object is between C and F, the image formed will be real and inverted beyond the C with a magnified size. In case 5, the object is placed at focus and the image displayed will be at infinity. In case 6, the object is placed between P and F, the image formed will be behind the mirror with a nature of virtual and inverted. The diagram shows the various cases of the convex mirror. In case 1, the object is placed beyond the C, the image formed will be of small size, virtual and erected. In case 2, the object is placed between C and F, the image formed will be of small size, virtual and erected. In case 3, the object is placed between V and F, the image formed will be of small size, virtual and erected. In case 4, the object is placed at F, the image formed will be of small size, virtual and erected. In case 5, the object is at C, the image formed will be of small size, virtual and erected. Now let us know about the lenses. Lens is a device which produces converging or diverging light rays due to refraction. There are two types of lens, they are convex lens and concave lens. The image biang displayed is showing the image formation by convex lens. In case 1, the object is between 2F and F, the image formed is of magnificent size and will be at beyond 2F of nature real and inverted. In case 2, the object is at F, the image formed is at infinity. In case 3, the object is between F and O, The image formed is of magnificent size and will be at between 2f and f nature virtual and erected. In case 4, the object is at 2f, the image formed is of same size and will be at 2f of nature real and inverted. In case 5, the object is beyond 2f, the image formed is of magnificent size and will be at between 2f and f of nature real and inverted. In case 6, the object is at infinity, the image formed is of same size and will be at f of nature real and inverted. Now coming to the concave lens. In case 1, the object is placed between 2f and f, the image is formed between f and c with a diminished size and in nature of virtual and erected. In case 2, the object is placed beyond 2f, the image is formed between f and c with a diminished size and in nature of virtual and erected. In case 3, the object is placed between o and f, the image is formed between f and c with a diminished size and in nature of virtual and erected. From the ray diagrams we can say that convex lens are converging lens and concave lens are diverging lens.
Now coming the next topic, that is refraction.
Basically, refraction occurs when light passes through different mediums with different refractive indexes. Refraction was explained by Snell's law, that is n1 sin theta 1 is equal to n2 sin theta 2, where n denotes the refractive index of a particular medium. Snell's law also states that if theta 1 is large and theta 2 is tending to 0, then it is assumed that the light will totally gets reflected. This phenomenon is called total internal reflection. Some of the examples for this type are mirage and polarization is the property of a wave which describes the oscillations like linear, helical and elliptical. Polarization of a wave can be determined by the Moll's law, which is by Ang displayed. One can also describe light in terms degree of polarization. Remember that the change in polarization by different refractive indexes is known as birefringement. The background image which you are seeing is a phenomenon of light known as diffraction. This generally occurs when a wave encounters an obstacles. This is also observed when a light ray travels in two mediums of different refractive indexes. Huygens' Fresnel principle states that in a wave propagation each and every point of a wave front acts as a source for a new wave front. This principle had also proved the Snell's law with a clear explanation. Now coming to the next topic, dispersion. Dispersion of light simply means breakdown of light ray. The simplest scattering include the Thomson effect, which talks about the deflection by single particle. Scattering of larger wavelength is known as Tyndall effect. C.V. Raman stated Raman effect, which says that dispersion is due to inelastic scattering of photons by matter, which results in exchange of energy in the form of vibrations. The counterpart to the dispersion was given by Sir Isaac Newton. The picture being displayed shows you two prisms through which light when passed gets dispersed and then again gets out as a white light. Now coming to the next topic, that is photography. Photography involves both lenses and the medium in which the electromagnetic radiation is recorded in the film. For a perfect shot, the photographer follows the following formula named as reciprocity of camera and the shoot. The equation is exposure is directly proportional to aperture area, exposure time and scene luminance. Lens in the camera are preferred by the necessity, like normal lens for angle view of about 50%. Wide-angle lens for angle view of 60% and long-focus lens for angle view narrower than normal lens. Now coming to the last topic, that is radiation. Radiation basically means the transmission of waves. There are many types of radiations in our daily life: electromagnetic radiation, particle radiation, acoustic radiation and gravitational radiation. Basically, in order for an easy systematic study, they are categorized as ionizing radiation and non-ionizing radiation. Ionizing radiations are those radiations whose energy can ionize atoms. Some examples are UV rays, X-rays, alpha, gamma, beta and neutron radiations. Rest all radiations are considered as non-ionizing radiations.
After knowing about all these series, you may wonder that there is no contribution by me in any of series of light. Well, all my concepts and theories are the next level of these primitive versions, so explaining them will confuse you so much.
If you are really curious to know about my contribution in light, then check these topics, which are mostly related to the quantum physics. The very first one is photoelectric effect, which means the emission of free electrons from metal surface. Then the existence of light as an energy, or we can say existence of light as the photons. Then the dual nature of light, that is the particle and the wave nature. Along with them I had also constructed Einstein lightbox and had done a significant contribution in the radiation, that is the derivation of law of blackbody radiation. Now that you have learned about the microscope, let's learn about the telescope. A telescope is an optical instrument designed to make distant objects appear nearer, containing an arrangement of lenses, or of curved mirrors and lenses, by which rays of light are collected and focused and the resulting image magnified. The schematic here displays the parts of a telescope. The lens is the basis for the telescope's main view. It is among the most important parts of the telescope. It constitutes a convex lens, concave mirror. It collects and controls the movement of light and the view in which the sky is viewed. Optical tube. The telescope tube, or the optical tube, it enhances the setting of the focal length through controlling the knob, which is usually below the visual back. Therefore, it is an important part of the telescope. Finder scope. This is a minor telescope that is mounted on the main tube. It is used to locate the main object which is to be viewed. Let us learn about the types of telescope. The part of the telescope that gathers the light, called the objective, determines the type of telescope. There are two basic types of telescopes: refractors and reflectors. Refractor telescopes. The refractor telescope uses a lens to gather and focus light. The first telescopes built were refractors. Reflector telescopes. The reflector telescope uses a mirror to gather and focus light. All celestial objects, including those in our solar system, are so far away that all of the light rays coming from them reach the Earth as parallel rays. Because the light rays are parallel to each other, the reflector telescope's mirror has a parabolic shape.